Hi everybody, Patrick here from EngineeringShop.com, ElectronicLessons.com, and PaintballProps.com. I've been piddling around with some more wireless power transfer circuits, and I've come up with one that has relatively good efficiency, certainly miles above where I was, and this actually inspired me to make a kit, a prototyping kit for those of you who are interested in prototyping your own wireless transfer kit or a transfer module. It's going to offer a lot of customization. I'm working on the PCB right now. In any case, I've got my transmitter right here, my receiver right here. The receiver is just a rectifier setup, and there's no capacitor, there's nothing. What I'm doing is I'm measuring the short circuit current with my multimeter. So basically the receiver draws as much power as it can from the transmitter, and of course the closer the receiver coil is to the transmitter coil, the more power is pulled across. Now, when the receiver is not loaded, or connected to my multimeter in this case, or if the receiver coil isn't anywhere near the transmitter, then the transmitter, when powered on, sits at around 90 milliamps. So its standby current is about 90 milliamps. And what happens then, if I load my receiver and I put it close, then it starts pulling more current across, and the efficiency is actually pretty good, for one of these circuits. When I get the receiver coil really close to the transmitter, I can pull about 240 milliamps, and the transmitter will sit at around 450 to 500 milliamps. So obviously not a fantastic efficiency, but the best I've come up with so far. So let me give you a demonstration. Right now, the coil distance between the transmitter and receiver is about 1 centimeter, give or take. I haven't plugged it in yet. I've got my multimeter set to milliamps DC. Plug in the transmitter. So right now, the transmitter is pulling 124 milliamps, and the receiver is seeing 65 milliamps. So if I put that closer, at about 3 centimeters, I've got about 7 milliamps. Right now the transmitter and the receiver are about half a centimeter apart, and I'm pulling almost 100 milliamps, and the transmitter is pulling 210 milliamps. Put it right close to each other. I can pull more than 200 milliamps, and at this point the transmitter is pulling about 500 milliamps, so the efficiency drops off a little bit there. But I've got a roughly 40% efficiency when I'm actually pulling on the receiver. So the best I can get side by side is about 230 milliamps, and at this point I'm pulling about 600 milliamps on the transmitter. So not perfect, but certainly a step miles ahead from where I was. 50 milliamps at 1 centimeter isn't too bad either. I'm pretty happy with that. Anyway, I'm going to be making this hopefully a Kickstarter down the road, and I'm making it so that you can completely customize your circuit. Lots of customization options. The FET I'm using is the IRF 540. If I do make that Kickstarter hopefully soon, then the schematic obviously will be included there. So thanks for watching. I just wanted to show it off. My multimeter again is connected on the rectified side. If I put a cap there, I might see a bit of a different fluctuation on the current draw, but this is just a very simplistic receiver. The transmitter is a bit more in depth, but I wouldn't say overly in depth. So thanks for watching, guys. Hopefully you found this interesting.